Welcome! In this group of videos, we're going to cover Chapter 7, which is List and Tuples. First, we'll talk a little bit about sequences. A sequence is an object that contains multiple items of data, and these items are stored in memory in sequence one after another. Now, Python provides different types of sequences, including list and tuples. The difference between a list is that it's mutable, and a tuple is immutable. I know you're already asking yourself, Professor, what's the difference between mutable and immutable? Well, immutable means you cannot change after creation, and mutable can be changed. So let's say that again. Mutable can be changed. Immutable means after you've created it, you cannot change it. Python has what we know as list, which is an object that contains multiple data items. Each item in a list is known as an element. To set up a list, we go list variable name equals, and in square brackets, these little brackets, we list out our items separated by a comma. A list can hold items of different types. So you can have an integer, a float, a string, all within the same list. The print function can be used to display an entire list, while the list function can convert certain types of objects to list. On this slide, we see a graphical version of list. The first one we have here is a list of integers. And the squares that we see on the right kind of represent what it looks like in memory. We have the 2, 4, 6, 8, 10 right next to each other in a sequence within memory. The second list is a list of strings. Also, as you can see by the squares, they're in memory right next to each other. And that third one, we called info, is multiple different types. It looks like we have a string, we have an integer, and a float, all in the same list. The repetition operator allows us to make multiple copies of a list and join them together. The star symbol is a repetition operator when applied to a sequence and an integer. The sequence is always on the left, then our operator, and then the numbers of times we want to multiply that list and join it together. We also want to be able to iterate over the list. To do this, we're going to use the iteration operator in a for loop. So we say for, x is our pointer to the items in the list as we loop through them. N is our operator that says we want to iterate over the list. And the list is the name or the variable name of the list that we want to iterate over. Indexing. The index is a number specifying the position of an element in the list. If we go back up to our slide before, this X is the index. It points to where we're going to be in the list. It enables access to each individual item in the list. Now, it must be said that for Python, in many languages, our indexes always start at 0. So the second item in a list is 1, while the first item is 0. Remember, Python is what's known as a zero-indexed language. That means the first item in a list will be 0, while the second item is 1. Negative indexes identify positions relative to the end of the list. So if you ever want to go backwards in the list, you can use negative numbers, and -1 identifies the last element, while -2 identifies the next to last element. One of the more common things that we're going to use is the len function. The len function returns the length of a sequence, such as a list. Oftentimes we need to know what the length of a sequence is because we don't know ahead of time what the length is. And part of going through and being able to iterate over a list or just know how many items are in a list, we want to know that len function. As we talked about in previous weeks, the len function helps us when we get an index error exception if we have an invalid index. An invalid index happens when we try to increase our index beyond the length of a length of a list. So an example of using the len function is, again, our variable name size equals len, and in parentheses, the list that we want to know the length of. It returns the number of elements in the list, so the index of the last element is always len in your list minus 1. The minus 1 is because, remember, the length that's given to us is how many elements are in the list. But because our index is always 0 based, we need to take 1 off so we don't accidentally go 1 past the end of the list. We can use this to prevent those index errors exceptions when iterating over a list with a loop. I know back when we were talking about mutable and immutable, you probably said to yourself, man, I just need to know more about mutable. Well, mutable sequences are those items in a sequence that can be changed. Lists are mutable, and so their elements can be changed. An expression such as list index 1 equals new value can be used to assign a new value to a list element. You must use a valid index to prevent raising of an index error exception like we talked about on the last slide. To recap this, lists, because they're mutable, you can change an element within the list. To do that, we would use the list and the index number of the item we want to change and equals the new item or the new value. We can put two lists together. We can concatenate those lists. The plus operator would be used to concatenate two lists. It cannot concatenate a list with another data type, such as a number. The plus equal augmented assignment operator can also be used to concatenate lists. We can splice a list. So if we have a list and we want a span of items that are taken from a sequence, we can slice them. List slicing format is where we take the name of the variable of the list variable, and in square brackets we specify the start and the end of the piece of list we want to slice. Span is a list containing copies of elements from start up to but not including end. This is important to understand. The end is exclusive. Start is inclusive. So the start will be in our span, but the end will not. If the end is not specified, the length of the list is used for the end index. If we don't specify the start, 0 is used for the start index. Slicing expressions can include a step value and negative index relative to the end of the list. A step value allows us to only bring back certain values between that start and end, which allow us to skip every so many items. You can find items in a list with the in operator. So that in operator is able to determine whether an item is contained in a list. That general format is item, end, the list variable name. It returns true if the item is in that list or false if it's not. You can also use the not in operator to determine whether an item is not in a list. When we come back, we're going to talk more about additional list methods and useful built-in functions.